Hello, my name is Ali Turfa. I am presenting on the paper Extending PICO with Observation Normalization for Evidence Computing. This work is a collaboration between myself, Hao Liu, Latoya Stewart, Tian Kang, and Chenhua Wang at the Columbia University Department of Biomedical Informatics. Evidence-based medicine, or the practice of using the best available medical evidence to guide the care of patients, is widely considered the gold standard for medical practice. However, the large and increasing amount of medical literature, and by extension medical evidence, in addition to the hectic schedule of clinicians, limits the practicality of using evidence-based medicine at the point of care for patients. The PICO framework, which captures the population of interest, the intervention and comparative treatments under consideration, as well as the outcome measure with respect to which they're being compared, can be used to formulate medical question and is widely adopted as sort of a guide for the literature search for evidence-based medicine. To that end, much of the current work on PICO has focused on its use for document indexing and retrieval to assist in this search. However, while this does limit the body of documents that need to be reviewed, it doesn't change the fact that they must still be manually reviewed, which is a time-consuming process. And while there have been efforts to summarize the findings in medical literature, these are presented as free text, which is a limitation in that if there's a large enough body of literature, it still might be unfeasible just to review all the summarizations, and there's no direct way to summarize summarizations. Our contributions are therefore twofold. We extend the PICO framework to include observation elements to represent medical findings. This allows us to use the same framework to represent the questions as we do to represent the answers to those questions. In addition, we implement and evaluate a framework to normalize observation elements for use in evidence computing tasks with respect to their statistical significance and the clinical or measurement effect of the direction, which I'll just refer to as significance and direction from here on out. This would allow us to, for example, if we have a body of 100 documents that come back from a PICO search, we could say 90 of them find a significant increase with respect to the outcome measure, and 10 of them find no significant difference, which allows sort of more efficient summarization. For the observation element, we are looking to capture the observed relationship between the intervention and outcome measure as specified in the text. We can use this to formulate a medical finding in terms of an intervention, observation, outcome triplet. So in this example below, the text states that good results were significantly higher in the ketorolac treatment group, where the outcome, observation, and intervention are annotated. And so we could represent this finding that the ketorolac treatment resulted in significantly higher good results. For the significance attribute, we are looking to determine if the findings are statistically significant, and it can take one of three values: true, false, or NA. For a more detailed view of the normalization process, please refer to the paper. I'll provide a high-level overview for both attributes here. First, we check for a significance indicator using regular expressions. This can be a p-value or explicit mention in the text. If no significance indicator is found, we assign to the NA category. If the significance indicator is presented in terms of a p-value, we compare to the threshold of 0.05 and assign accordingly. And if the significance indicator is text, we check the context for negations and then assign accordingly. For the direction, we are looking to capture the effect the intervention had on the outcome. It can take one of four values: up, down, change, or unknown. For the up, down, and change categories, we have defined a set of trigger words for each category that will map to that category. So for the normalization process, first we check for negations and assign unknown if a negation is found. This handles cases such as no difference was detected, or there was not we did not observe an increase in if the outcome might be like mortality or something like that. We then scan for each label's trigger words and assign to the category if we get a match. If no match is found, we augment the trigger word sets with the synonyms of the words in the set and then repeat the scan, assigning if we find a match. If no match is found, we then assign to the unknown category. At this point, I'd like to go through some examples to illustrate the normalization process as well as just a high-level view of the framework. So in this first example, the intervention outcome observation triplet is shown below, and then the relevant span of text is highlighted in yellow. The symptoms reduce significantly in all treatment groups. For this example, the significance indicator is significantly, and since there is no negation in the context of the text, this has a true significance. For the direction, reduce is part of the trigger word set for down category, so we would assign a direction of down for this example. In this next example, the PEF variability improved in the BDP group. So there's no indication of significance made here. So this gets an NA for significance. In addition, improve is part of the trigger word set for the up category. So we would assign the direction of up. In this next example, the relevant span of text is that bone-specific alkaline phosphatase decreased P less than 0.05 by negative 14.3 plus or minus 4.1% in the HRT alone group. So the significance indicator here is P less than 0.05. And since the p-value is specified less than the threshold 0.05, it gets a significance of true. For the direction, decreased is part of the trigger word set for the down category. And so we assign to that category. This final example, the relevant span of text is Cox model of overall survival where the effect of cisplatin was not significant. So the significance indicator here for the observation is this word significant, but since we have not, we have a negation. In the immediate context, we assign a significance of false. And there is no matching word to any of the direction trigger sets, so we assign unknown. In order to evaluate this normalization process, we devised two classification experiments, one for significance and one for direction. We took 200 abstracts and manually annotated them for their PICO elements, and then took a set of 150 of these intervention, observation, outcome triplets, and then manually labeled the significance and direction. This training set was used for calibrating the regular expressions and also the trigger word sets for the direction normalization. We then took a sample of 50 different abstracts, annotated them for their PICO elements, and repeated the sampling to get the testing set, which was used for evaluation. The reason why we're defining these sets on completely different abstracts is to minimize the possibility that we get overlap where a triplet in the training set and a triplet from the testing set come from the same document, and so they're not necessarily independent sets. For significance, we present the results in terms of the class-specific performance and also the average performance between the training and the test set. For this case, we achieve a testing macro F1 score of 0.82, and the performance is generally consistent between the two sets. For direction, again, we present the class-specific performances as well as the average performances. In this case, we achieve a macro F1 score of 0.73 for the testing set. And while the performance is generally consistent, we do notice an increase in the precision for the change class, and we attribute this to an increase in the size of the support of this class in the testing set. When we were looking at the errors that our normalization procedure resulted in, we noticed that most of them came from this issue of having disconnected spans of text comprising the true observation, which we could not annotate correctly. So in these examples, the observation that we annotated is going to be in bold, and the missing context is going to be highlighted in yellow. So in this first example, significant Doppler flow improvement was obtained in the L-arginine supplemented group. In this case, we were not able to capture the significance indicator in the observation, which would have resulted in an incorrect significance measure. In this next example, in the control group, soccer training caused an improvement of smaller magnitude in the 10-meter and shooting speed, P less than 0.05. Again, in this case, the significance indicator is separated from the annotated observation by these outcome measures, the 10-meter and the shooting speed. In addition, the trigger word sets had some coverage issues in the testing set where words like alleviate, prolong, and impair, which just didn't show up in the training set, were more common in the testing set. And so this is sort of a brittleness in the direction detection setup that we have. This dovetails really nicely into future work. We recommend using more robust direction detection methods, such as like neural methods or more semantic-based approaches, in order to improve generalizability to different sets of documents, as well as reduce the manual overhead of having to maintain a set of trigger words for each class. From a representational standpoint, there is some ambiguity in cases such as hypertension and blood pressure, where a clinical up, like an improvement in the patient's condition, would correspond to a numeric down, which would be a decrease in the actual values of blood pressure. Finally, beyond just summarization, this framework could be used for contradiction detection. At a high level, if you have these intervention outcome observation pairs for the same population, where the intervention and the outcomes are the same. So we're comparing the same treatment with respect to the same measure. If there is a contradiction in terms of the observations, for example, a significant increase and a non-significant finding, this could be a contradiction, and this framework can represent these without any modifications as it stands. In conclusion, the feasibility of implementing evidence-based medicine is limited by the manual process of synthesizing medical findings. We propose an extension to PICO to capture the observation and use them to formulate the medical findings. In addition, we also propose a normalization procedure which achieves F1 scores of 0.82 and 0.73 for significance detection and direction classification, respectively. Beyond the co-authors and our lab members, we'd also like to thank our funding grant, Bridging the Semantic Gap Between Research Eligibility Criteria and Clinical Data, as well as Dr. Matthew Spotnitz, Dr. Konstantin Stoyanovich, and Dr. Anna Stroplitz for helping us iron out the details of this representation and make our naming more informative. We'd like, if you have any questions, please contact me at at3473@columbia.edu. Thank you very much for your time.